Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Nurikabe Bridges by Blobs. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9 cell region contains the digits 1 through 9 exactly once each. We also need to divide the grid into a number of islands, which are orthogonally connected group of cells. Each island contains a single circled cell, so circled cells, and the digit in the circle indicates the number of cells making up the island. So for this 5, that means the island must be 5 in size. So you could have an island something like this, or it could be something like, it could just be a long line, or it could be like a line like that. That's possible too. And all the digits on an island must be orthogonally connected, which means you can go from any cell on the island to any other cell on the island just by going through edges, all while staying within the island. So this is an example of a valid island. This, however, is not, because to get from this cell to any other cell on the island, you would have to go through a corner, or you would have to go outside of the island, which is not allowed. So this is an island of 1. So obviously it's by itself. So that's fine. The islands are surrounded by a waterway, where a single orthogonally the islands are surrounded by a waterway, which is a single orthogonally connected group of cells. So that means all the water must be able to orthogonally connect to any other cell that is water. Because they're all orthogonally connected, and it's a single one. All caged cells are waterway cells, and a digit in caged cells indicate how many waterway cells are seen orthogonally from that position, including itself. Island cells block vision, and the waterway cannot form any 2x2 areas. So you can't have a 2x2 area of all water. So this is not allowed here, because this is a 2x2 area that's all water. You can have a 2x2 area that's all land, though. So keep that in mind. And the digit in all cages are waterway cells. And the digit in the waterway cell indicates how many cells it sees that are waterway cells. And island cells block vision. So this sees 4 waterway cells orthogonally, which means horizontally and vertically that it sees. So you could have all the waterway cells be there, which would mean this would be land and I guess it would have to connect something like that or something. But this would be a 2x2 area that's all water. Oh, that's interesting. Huh. I guess it could do something like that, right? And then this is land. So this is possible. Something like this. And then this is land. So this would see... So even if this is water... This is water here. But even if this is water here, it does not see that cell because land cells block vision. So it sees itself, 1, 2, 3, 4. It does not see anything past this land cell, and doesn't see anything past that land cell. So this is an example of how the islands work, and the digits in the cages. The islands are connected by a series of whispering bridges, which are the green lines. The end cells of a bridge are on 2 different islands. So this is on one island, this is on another island. The middle cell of a bridge is a waterway cell. So these have to be land, land, and waterway. Adjacent digits along a bridge differ by at least 5. So, for example, this digit here would have to be 6, 7, 8, or 9 because it must be 5 or more away from 1. But it can't be 6 because of 6 in the column, so this must be 7, 8, or 9 to be 5 or more away from this digit. And this is some people call them German whisper lines. I call them whisper 5 lines because I think it makes sense because it's very easily extensible. But no, when I say whisper 5, I mean it's the same thing as German whisper lines. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. So all the circles, we can't get all circles. All the circles and all the ends of the Whisper 5 lines are land. All the cages and all the middle digits on a Whisper 5 line are waterway. This is 1 in size, so this cannot be land. It has to be water. It must orthogonally connect to this cell, which is water. This has to orthogonally connect to the rest of the waterways, so it has to go to water there. This is part of the 5 lands. This water must orthogonally connect to the rest of the waterway, so it goes to go there. This is 4, so this must be 9 here. Oh, interesting. Because 4 is only 5 or more away from 9. So this has to see 9 cells. It doesn't see any cells here. It can see at most 1 here, so it must see at least 8 cells here. Well, if it sees this way, it's guaranteed to see those 2. So it must guaranteed to see all of these. And it could be either blue here or blue here. We're not sure which. This cell sees at least 3, but we don't know how many. This has to be a low digit, so it could be 1, 2, or 4. So on a Whisper 5 line, you'll alternate between low digits and high digits because what digits can be next to a low digit? Low digit being 1 through 4 and high digit being 6 through 9. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9. Which is why, and those are all high digits, which is why low digits have to be next to high digits. And this can't be 6 or 9, so this is 7 or 8, which must be next to 2 or 3 here because it can't be 1 because of 1 in the column. This sees at most 3 cells. Sorry, could see at most 4 cells because these are both land. And this can't be 4, and it does see at least 3, so this must be a 3 here. This sees 9. This sees at most, it sees 2 or 3 cells in the waterway. And it can't be 3 because of 3 in the column. So this is 2. This has to be 8 or 9 to be next to 3 on the Whisper 5 line. So this sees 2. Oh. Wait, no, this is not a waterway. Sorry, this is not a cage, so we don't have to worry about that. That's wrong. This is 8 or 9, though, still. We don't know anything about that. This sees... could be a lot, actually. This sees at most... It could be 5. At most. It cannot be 1, cannot be 3, so this is 2, 4, or 5 here. This sees at most 1, 2, 7. So it sees at least 3 and at most 7. Well, Can't be 4 or 6 here, because 4 can only be next to 9 on a Whisper 5 line, and 6 can only be next to 1 on a Whisper 5 line, and these are both next to 2 unique digits on a Whisper 5 line. So it has to be 3 or 7 here. That's interesting. This cannot connect to each other because each island has only one circle, so this must be blue. Oh, this is green too. This has 5 cells. So it must connect to here. And this is blocked off by this. This could continue on that way, actually. No, it cannot. If it goes that way, it has to connect that way, and this blue is not going to be orthogonally connected to the rest of the blues. So this must orthogonally connect this way, which means this can't be blue, this is green. Oh, and this is size 4. So this has to be 4 in size. So this has to orthogonally connect here, and it can't go this way because then this is not 5 in size. We have 3 or 7 here. So if this is 3, this is 8, 9. And if this is 3, this would have to be 8 and 9 to be next to it on a Whisper 5 line, but we have a 9 in the box, so this can't be 3. This must be 7, which is next to 1 and 2. And this sees 7 cells as waterways, so then all of these are waterways. We can't have a 2x2 area that's all blue, so this must be green. This can't be all blue, so this must be green. This must be 3 then going this way, which means that's done as a whole, so this is blue. Therefore, we have a 2x2 area that has 3 blues, so this can't be blue, it's green. And this cannot orthogonally connect to this cell, because then it would be too large. Well, this would say it's size 3, this would say it's size 6, and that's not possible. So this must be all green. This has to be blue here then, this for it to fill 6 islands. This sees at most 4 now. But this cannot be island, because if it's island, it has to orthogonally connect to a circle, and it's not going to be able to because this is only size 3. So this must be blue here. This is 4, and we have a 2x2 area that has 3 blue, so this can't be blue, that's green. This is done as an island, and this must orthogonally connect to the islands, so that's done. So this is sees 4. This sees 1, 2, 3, 4, 5, 6, 7 at least, and it could be 8 and 9 also. This sees 1, 2, 3, 4, 5, 6, 7, and then maybe 8. So 7 or 8 is there. That sees 7, it's 1 or 2 there. 8 and 9 can be next to 1 through 4 here, but it cannot be 3 because of 3 in the column. This sees at least 5, so does that. So this is at least 5. We have 5, 6, 7, 8, 9. This can't be 5 because of 5 in the column. This can't be 6 because of 6 in the box. So this is 5, 7, 8, 9 there. This must be 1 or 2 to be next to 9. But it cannot be 3 or 4 because of 3 or 4 in the row. So this has to be 7 or 8 to be next to 1 or 2 because it can't be 6 or 9. This must connect to the 6 somehow. Okay. This is 2x2 area that has 3 islands, so this is land. This land must connect orthogonally connect to a circle, so it has to go down that way. That means it connects to one of these two. We're not sure which. This is all orthogonally connected, so that's okay. This must orthogonally connect to waterway, so that's there. So this sees 8. 1, 2, 3, 4, 5, 6, 7, 8. Which eliminates 8 in the rest of the row. Also, this cannot be 5 anymore because it sees at least 6 cells. This sees at most 1, 2, 3, 4, 5. So it cannot be 4 because of 4 in the column, so it's 1, 2, 3, or 5. This doesn't see any cells there. It sees at least 5 there. It could be up to 7. So this is 5 or 7. Cannot be 7 because of 7 in the column. So this sees 5, which means this cannot be island here because, or waterway here because, so it has to be island. It must orthogonally connect to the island. And then if this is green, this would have to be blue. But the problem with that is this blue one orthogonally connect to the rest of the blues. So this has to be blue here, and this must be green here to form a 6 size island. Therefore, it's blue there. This sees only 6 cells that are waterways, so this is 6. This sees only 7 cells, which are waterways, so that's 7, which eliminates 7 here, so that's 8. This sees 1, 2, 3, 4, 5, 6. Can it 7? Can it ever see 9? So 6, 7, 8, 9 would force this to be also waterway, and it would see more than 9. So this cannot see 9. It sees 7, which means this is green because it sees these 6 and then 7th there. That means this can't be 7. This is 8. This sees more than, this sees at least 3. So let's see. Ooh, whoa, what the heck did I do there? This can't be 1 or 2. It sees at least 3 here. This sees at most 5. So we have 1 through 5 there. Okay. One of these digits must be high as a digit. And if it's high, it has to be 7. So it must be 7 with 1 or 2 in these cells because 7 can only be next to 1 and 2 on a Whisper 5 line. That means we have a 1, 2, 7 triplet in column 8, which eliminates 1, 2, 7 in the rest of the column. So that leaves these as 3, 4, and 5. This cannot be 4 because of 4 in the box. So 4 in column 8 has to be one of these 2 digits here, which means this cannot be 4 here. This is size 9. We have 1, 2, 3, 4, 5. This is part of that island. 6, 7. This cannot be green, 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 green here because then this blue would not orthogonally connect. So this has to be green here. So it orthogonally connects either to here or to here. We're not sure which. This does not see 5 cells. So it's 1, 2. It can't be 1 cell that it sees, so it's 2 or 3. Right, you can't have 1 in a cage because it must see more than 1 cell. Anyways. 1, 2, 3, 4, 5, 6, 7. Only 2 more of these can be green. This sees either 3 cells or 5 cells. Where is 7 in this upper left-hand box? Cannot be here because of 7 in the row, and can't be here because they're filled out, so 7 has to be one of these 2 digits, which means this cannot be 7. So where is the 7 in column 8? It has to be here. So that's 7 as a high. This is 1 or 2, which must be next to a high. So this is 6, 7, or 8 there. Where is 2 in this upper left-hand box? Can't be here because of the 1, 2 pair in the row, so it has to be here. This must be 2, 7 as a pair, which eliminates 2, 7 in the rest of the row, so this can't be 2 or 7. It's 1, which eliminates 1 here, so that's 2. Remaining digits in row 6. We have 1, 5, and 9. This can't be 5, so this is 1 or 9. It's 1, 5, or 9, 1, 5, or 9. Okay. This sees 4 cells. It sees 1, 2, 3, so that must be the 4th. So this is blue, which means this can't be blue. That's green. Let's see, what else? Oh, we have whisper 5 lines here. Okay. If this is high, it would be 7. And that would have to be next to 1 and 2. If this is low, it cannot be 4 because it's next to 2 unique digits on a whisper 5 line. It couldn't be 8 or 9 because of 8 or 9 in the column. So it could be 1 or 2 here because it can't be 3 because of 3 in the column. 1 or 2 could be next to 6, 7, 8, 9. This can't be 6 or 8, so it would be 7 or 9 here. And this can't be 7, so it'd be 6, 8, and 9 there as a possibility. But neither of these could be 8 because of 8 in the row. Okay. Remaining digits in this upper left-hand box. We don't have 1, 3, 4, 2, 7, or 8, so this must be 5, 6, and 9. This can't be 6 because of 6 in the column. This 5, 6, 9 triplet eliminates 5, 6, 9 in the rest of the row, so this can't be 5. It's 3. That leaves this as 8 here. 3 eliminates 3 in the rest of the column, so this is 4 and 5 here as a pair. This sees 2 or 3. We're not sure which. Oh, we have a 2, 3, 2, 3 pair in row 4, which eliminates 2 and 3 in the rest of the row. So no 2 here. This is 1 or 4. Remaining digits in this upper right-hand box, we have 2, 5, 6, and 9. Well, 2 and 9 cannot be here, so 2 and 9 have to be here as a pair, which forces this to be 5, 6 as a pair. That eliminates 5 and 6 in the rest of the row, so this is 3 and 4 as a pair, which leaves the remaining digits in this upper central box as 6 and 8. This 8 eliminates 8 here, so this is 6, which eliminates 6 here, so that's 8. 7 here eliminates 7 here as a possibility. So if this is high, that makes this low, which would make that high. But if this is high, that's 9. So this can never be 9 here. So if this is high, low, high, 2 can't be here because 2 cannot be next to 6 on a whisper 5 line. So this must be 1 then in that case. So either way, one of these is guaranteed to be 1. We're not sure which. Okay. Remaining digits of this lower central box. 4 can't be here. Okay, so remaining digits are what? 1, 3, 4, 5, 9. This can't be 4 because of 4 in the column. No 5 here, no 5 here because of 5 in the row. Remaining digits of column 4 are 1, 2, 4, and 7. This can't be 7 here because of 7 in the row. You could have green, green here, and blue, blue there. Or blue, blue here, and then green, green here. We don't know which. We're guaranteed 4 is one of these two. Where is 3 in column 5? Cannot be here because of 3 in the row. This is filled out, and this digit has to be next to a 7 on a whisper 5 line. Can't be here because 3 in the box, and these are filled out, so 3 has to be here. So this is 3, which makes this 4. Where is 4 in column 5? Can't be. This can't be 4 because of 4 in the row. This can't be 4 because it must be next to 7 on a whisper 5 line, so 4 has to be one of these 3 digits. Which means we can't have 4 in the rest of the box, so this can't be 4 here. This is 1. No 1 or 4 here. 1 eliminates 1 here, so that's 2, which eliminates 2 here, so it's 1. That eliminates 1 here, so this is 7, which is next to 1 and 2 as a pair on the Whisper 5 lines. And this can't, the 2 eliminates, wait. I have, anyways, this is still 1 because it can't be 4. But, yeah, I made a mistake here. So this is not 1, 2, it's 4 or 5. And this can't be 5 because of 5 in the box. So this is 4, which makes that 5. Okay. Apologies for that. Made a kind of error there. 7 is next to 1 or 2, which means we cannot have a 1 here. Remaining digits, so where is 4 in row 8? Cannot be here because the 4 is in the boxes. This cannot be 4 because of 4 in the column, so 4 has to be here, which means this can't be 4 here. Whereas 5 then in this lower right-hand box cannot be here because of 5 in the box, or 5 in the row, and these are filled out, so 5 has to be one of these 2 digits, which eliminates 5 in the rest of the column. So this can't be 5, this is 6, which eliminates 6 here, so that's 5. 6 eliminates 6 here, so that's 7 or 8. Remaining digits of row 8. We have 3, 5, 6, and 9. This can't be 5 or 6 because of 5 or 6 in the box. This can't be 3, so this is 5, 6, or 9. This can't be 6 because of 6 in the column. We have a 5, 9 pair in column 1 now, which eliminates 5 and 9 in the rest of the column. So this has to be 2 or 3 here. This can't be 3 because of 3 in the row. So that makes this 2, which makes this 3, which makes this 2. So it only sees 2 cells. Therefore, this is not water, it's land. We have 1, 2, 3, 4, 5, 6. It must connect to these because this must connect to a circle. So it must connect there. And these must be 2 waters, and therefore this is 5. Which eliminates 5 in the rest of the row. So this can't be 5, it's 9. This can't be 5 or 9, it's 6. This can't be 9 because so it's 3. 9 eliminates 9 here, so it's 5. This can't be 5 or 6. It's 9, and this can't be 5 or 9. It's 6. Okay. This can't be 9 because of 9 in the box. This can't be 2 because of 2 in the box. And now the rest we do from normal Sudoku. Remaining digits of this cell is 1, 2, or 9. Cannot be 1 because of 1 in the column. Remaining digits in this lower left-hand box are 1, 2, 5, 1, 2, 5, 8. Remaining digits of column 6 are 2, 7, 8, 9. And this can't be 2 or 9 because of 2 or 9 in the row. No 2 here because of 2 in the row. 2 eliminates 2 here, so this is 9, which makes this 2. 9 eliminates 9 here because of 9 in the column. Remaining digits of column 7 are 1, 3, and 6. This can't be 6 because of 6 in the row. We have a 1, 3 pair in column 7, which eliminates 1 and 3 in the rest of the column, so this is 6 here. Remaining digits of this right central box are 1, 3, 7, 8. No 3 here because of 3 in the row. Okay. We have to have a 6 somewhere in column 5. Can't be either of these cells, so it must be here. And we have 4 with 1, 2, or 9. Cannot be 1. So 4 with 2 or 9 as possibilities in column 5. And this can't be 2 or 9, so this must be 4. Which eliminates 4 here, so this is 2 or 9 here. Because it can't be 1 because of 1 in the box. Okay. Remaining digits of row 4, we have 4, 5, 7, 8, 9. This can't be 4 because of 4 in the column. No 9 because of 9 in the column. Remaining digits of row 6 are 1, 5, 7, 8. Okay. Um, We have a 1, 9 pair in row 7, which eliminates 1, 9 in the rest of the row. This can't be 1. It's 5, which eliminates 5 in the rest of the box. And 5 in the rest of the column. So one of these two is a 5. Okay. Um, hmm. This 5 eliminates 5 here, so this is 4 and 5. That means this can't be 5. This 4 eliminates 4 here, so it's 1, which eliminates 1 in the rest of the column. We have a 2, 7, 8 triplet now in column 2, which eliminates 2, 7, 8 in the rest of the column, so this can't be 7 or 8. It's 4. 1 eliminates 1 here, so it's 3. This can't be 1 or 3. It's 7, 8 as a pair, which eliminates 7, 8 in the rest of the box, so this can't be 7 or 8. It's 1. No 1 here. This is 7, 8 as a pair in row 6, which eliminates 7, 8 in the rest of the row, so this can't be 7 or 8. It's 5. 1 eliminates 1 here, so it's 9, which makes this 1, which eliminates 1 here, so that's 2, which makes that 1 there. 2 eliminates 2 here, so that's 9. 2 eliminates 2 here, so that's 9, which eliminates 8 and 9 here, so that's 8, which makes this 7, that 8. This can't be 7, 8, or 9, it's 2. This 8 eliminates 8 here, so that's 2, which makes this 8. 2 eliminates 2 here, so it's 7 and 2 here. 8 eliminates 8 here, so it's 7. This can't be 7 or 8, it's 9. This can't be 9 or 8, it's 7. This can't be 7, it's 8. 3 eliminates 3 here, so it's 1, which forces 3 in the corner. And we celebrate because we finished the puzzle. I don't think I would put this as very easy. I think the execution on this is fairly difficult. The logic behind it isn't too hard, but the execution is harder than I would classify as a very easy puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.